So in my last video, I showed the difference between recursive algorithm and iterative algorithms, where we use a loop, and here we call the method itself at some amount of times. So another thing I want to show is how an algorithm like this can look. So in this first example that I gave, it works like this. I have a recursive method, which I call, that makes one object, and then it keeps creating the next object until it created all the objects that I need. But it doesn't necessarily need to be this way. Sometimes we can also have a recursive algorithm like this, where we could create more than one object. In this case, it probably wouldn't make any sense to create more balloons. However, sorry, we could, for example, add 3 balloons instead of 1. So we could do something like this, add object, and then we could put the x value, we could put -20 on this one, and then +20 on this one. So we would create 3 balloons per iteration instead, and then create something like this. So we could do something like this, but this is not really utilizing that much the recursiveness. I think I have another demonstration that shows it better. So let me show you this little program that I made. So I'll just close the balloons here. So I created this program here. So what it is, it's one fly here giving birth to 3 flies. I know normally they go to through a larvae stage or something, but let's just ignore that for now. It kind of creates 3 flies from one fly. And the way that I do that, I have a fly which is just a very simple class. It actually doesn't do anything at all. And I do everything in the my world. So what this code does here is that I want to show here that, like the other example, I have my method here, my iterative method, and in this specific scenario, I call this have children. I also have something else that's quite interesting. I have this one called stop child, which is really the amount of levels I want to go through of this iteration, meaning I want actually to have to go through a certain amount of times. So what the code does is it actually creates 3 children. It creates a fly child, like this one. I call this fly child 1. And then I have the mother of that child. I get the x value, and then I do some spacing calculation to make them kind of evenly distributed from the mother. 1 in the center and 2 to the sides. And what I do then, I make the spacing a bit smaller here each time that I go through the recursion. So if we look at this one here, that means that I first create a fly here, because in this version here they need to have a mother. Then I add that object, that's the fly we see here, at this specific location, and then I say have children, and I send the fly to the method that I want to have children. I set the first couple of spacings here. 220 is the initial spacing in the x direction, and 50 is the initial spacing in the y direction. And then I say I want 4 levels. If I change levels, you'll see I'll get another, and I can go for another level as well. And I'll get even another level. So now there's a lot of flies and the spacing isn't working all that great, but that's because I'm dividing here. Probably should have been 2 here, yeah. So it's more evenly distributed, yes. So so now we can see that this grows exponentially somehow, or something that looks exponential, because this fly gets 3 and these 3 gets 3. So this way, now we are kind of branching out. So if you saw the tree that I did in my PowerPoint here, this kind of tree, it's the same thing. 1 becomes 2, and these two also has 2, and these two also has 2, and so forth. In this case, it's just 3 instead. So each of these flies will create 3 new flies. So the way that I've done this, I have my stop parameter here, and I start setting that to 6, and then I'm saying as long as this stop child is larger than 0, then do this part here. And then I initiate the first fly child here, and then I call the same method again on that fly. So I'm saying the first fly child should also have 3 children, and then I say stop child -1, which is very important. So that means for the first fly, it just goes in here and creates the object, and then has the child for the next fly, and the next fly, and the next fly, and the next fly. But at some point down here, it's going to stop because stop child becomes smaller than 0. It becomes -1, and then it will never run this code, and the recursion stops. And we have to do this again because otherwise we get this problem with the Stack Overflow exception. So for example, if I remove it just for one of these, we get the Stack Overflow exception for these here. So so we have to be very careful with these stop clauses here, or these stop parameters, to make sure that they work correctly. Otherwise we can get into some errors. So this is kind of another way where we branch out like this. So maybe this is a bit simpler, maybe it's more complicated. It's certainly a different way to use these recursive algorithms. In the next video, I'm going to show an animated version of this, which is somewhat different and a little bit more complicated, and I'm also going to use flies.